السلام عليكم جميعا. Okay, I'm going to talk about the graphs of displacement and velocity. Okay, and the next video is going to talk about falling object. So this graphs, in brief, this is 1, 2, okay. This is displacement in meter. It's time in second. In the first graph here, the body at rest, of course. It means that is not moving. And the slope, that's equal delta y over delta x, which is delta d over delta t, and that's equal velocity. So in this case, there is no velocity since the slope is equal to 0. So remember, in the displacement time graph, always, okay, we need to understand that the slope is velocity and this one is equal to 0. The second one, again, displacement is in meter, time in second also. So this is the graph. So here I want to show you that this body is moving with constant velocity. Why? Because it cross equal displacement or change in position equal, okay, displacement on the equal interval of time. So delta t delta y over delta x, which means delta d over delta t, and also this is going to be giving you a positive value of velocity. So the slope here has a positive because the velocity is constant, so and my position is increasing along the graph. The third graph here, okay, displacement in meter, time in second. Okay, this describes that the object is moving with constant velocity, but in the opposite direction, which means that the slope, which is delta d over delta t, should give you negative velocity because I'm moving backward. So if my position, as an example, 10, it becomes 8, then it becomes 6, it becomes 4, and so on till I reach 0. Maybe I'm going now backward. So that's my position is backward. So the slope here is going to be give me a negative value. The other type of the graph is velocity against time. Velocity meter per second against time, which is second. Okay, this graph. This type of graph is really critical. We need to understand three things from this graph. Here, constant velocity, because the body, okay, remains constant, moving with constant velocity. As an example, 10 meters per second. It's moving, but it's constant. Okay, this is the information number 1. Information number 2, that the slope is equal delta v over delta t, which means it's acceleration. So the slope here represents the acceleration. Okay, so in this case, you need to understand that, okay, the slope here represents acceleration, yes, and yeah, the slope here represents acceleration. Okay, and since the slope, it has a constant velocity, which means the slope here is going to be equal 0 because the velocity is constant, so there is no change in the velocity. And one more thing, the third information here that you need to understand, that velocity is equal distance over time, displacement over time. So displacement is equal velocity times time. So this case, velocity times time, this is time, and that's velocity. So displacement is equal velocity times time, which is the area of rectangle. So always remember three information from this graph. First of all, it is moving with constant velocity, which is equal 10 meters per second. The slope of this, which is delta v over delta t, acceleration equals 0 because it's constant velocity, and the displacement is equal velocity times time, which is the area of what? The rectangle. Okay, we are almost there. And in this graph, guys, velocity meter per second, time second, I'm gonna make it short. أو let's just خلينا نعملها هيك أحسن. Yes, this one. So in this case, first of all, velocity is increasing. Second, slope, it has a value delta v over delta t, and that's equal acceleration. Okay, as an example, let's say this is 10, this is 20, this is 5, this is 10. So what's the slope? So the slope is equal delta v over delta t, that's which is equal delta y over delta x. Yalla, this point is 10, 20, this point is 5 and 10. So that's going to be y2, which is 20, minus y1, which is 10, over x2, which is 10, minus x1, which is 5. 20 minus 10, 10 over 5, and that's equal to meter per second square. Okay, and okay, what about Mr. the displacement? The third information, the displacement. This is, I need to understand, this is a triangle. So remember, displacement is equal triangle, half times base times height, which is half times velocity times t, and that's half. What's the velocity here? Total, which is 20, and the total time, which is 10. So 10 times, which is going to be the 100. 100 what? Meter. That's a displacement. Okay, so this is in brief the velocity displacement graph. Okay, I'll give one more example so you'll make sure you understand what I'm doing. Okay, this is displacement meter, this is time in second. Say 10, 5, 5, 20. Now tell me, this is displacement time. What's the slope? So Mr. the slope is velocity. And what's its value? It's delta d over delta t. Those are the points. This point is 5 and 5. And this is the other point, which is 10 and 20. So that's going to be 20 minus 5 over 10 minus 5. 10 minus 5, which is equal 15 over 5. And that's equal 3 meter per second. This is velocity. Okay, why? Because this is displacement time graph. Last one. Oh. Okay. 100, 10, 20, velocity meter per second, time second, 10, 100, 20, 100, 0, 0. So slope 1, slope 2. I want the acceleration at point 1, at 1. The acceleration is delta v over delta t, and that is equal to 100 minus 0 over 10 minus 0, and that's equal 100 over 10, which is equal 10. 10 what يا جماعة? Meter per second square. For this is part 1. At area 2, which is the slide 2, of course delta v over delta t. أصلا ما في داعي أحسب it's 0، بس خلينا نعملها للطلاب اللي حابين يفهموا. 100 minus 100 over 20 minus 10, 0 over 10, and that equals 0 meter per second square. So slope 1 and slope 2, that's the acceleration. Now let's talk about last thing, which is the displacement. So displacement, I have two areas. If I want to find the displacement here, so displacement is equal half times v times t, which is half. Why half? Because it's a triangle. Okay, it's a triangle, so what was that? Remember, what's the v? 100. What's the t? 10 times 10. So that's going to be 500. 500 what? Meter. And for the rectangle here, displacement is equal 20 minus 10, 10, and the height 100 times 100, and that's equal to 1000 meter. So from 0 minute to 10, sorry, من 0 second to 10 second, it's 500 meter. From 10 second to 20 second, it's 10 also second, and sorry, 1000 meter. But if I want, I'm asking for the total displacement that traveled. So it means that I'm asking for the full graph, which is the trapezoid, as you can see here, all of this. Okay. Okay. So in this case, its total displacement is equal 500 plus 1000. That's equal what? 1500. Okay, meter. Thank you very much for watching, and hope it's this clear. This is for the section 2.1, and there is a video already I sent for section 2.2. Of course, there will be a video for section 2.3 from the Holt McDougall book, okay, which is the motion in one direction. Thank you for watching. See you later.